Hello everyone, and today I would like to talk about electrostatic potential as a predictor for water placement in atmospheric clusters. Small nanoparticles are universally present in the atmosphere where they influence the global climate, general air quality, and through that our human health. The continued consumption of the resources of the Earth have brought climate changes across the globe, and with that there is increased need of understanding the mechanisms of atmospheric processes. The large concentration of oxygen in the atmosphere makes it highly oxidizing, which provides the ability to oxidize volatile organic compounds. And these can lead to secondary organic aerosols, where they can act as cloud condensation nuclei with water droplets condensing around the secondary organic aerosols, forming clouds that can reflect sunlight back into the space, leading to a cooling effect, as you see on the left side. And this has been estimated that 15 to 55% of the global CCN concentration may be originating from these newly formed particles. The mechanism behind how these new particles are formed and the growth into these CCNs are one of the biggest uncertainties in climate models at the present time. And mentioned earlier, the atmospheric particles impacts not only atmospheric processes but also our human health, where studies have shown that they increase the risk of lung cancer, cardiovascular diseases, and premature death. Then our methods. To investigate the fundamental nuclearization processes and which atmospheric vapors participate in the particle formation, quantum chemical calculations were useful. To investigate the cluster formation, it is though often necessary to sample a very large amount of configuration for potentially important conformers. And for that we use a method developed by Jens Kielgaard, where he introduces a way to systematically sample the full conformation space of our system. Unimportant conformers were then removed through a Boltzmann sorting, while redundancies are removed through a root mean square deviation comparison. In my study, we did an investigation of the electrostatic potential of clusters containing ammonia, sulfuric acid, water, and the organic acid 3-methyl 1.2.3 potent tricarboxylic acid, also called MPTCA. And we use density functional theory to make our calculations. Now for our results and discussion. As you see around our particles, we have a so-called cloud. This is our electrostatic potential. The yellow/orange parts are electronegative parts of the system. The green are the more neutral parts, and the blue are the electropositive parts of our system. In the original system, without any water, around ammonia we see there's a lot of electropositive energy, and around sulfuric acid there's real electronegative energy. When we place a water molecule into the system, it is placed around ammonia, and this contributes to also electropositive area, as we can see. Adding more water molecules into the system, they are then placed close to each other, the two water molecules, but still close to the ammonia. And by adding more water molecules into the system, when we have free water into the system on the left side down at the bottom, they are also placed around ammonia into the system, but at 4 water molecules on the right side, we see that the 4th water molecules are placed between our MPTCA and our ammonia. And we can see that around ammonia it becomes less and less electropositive as we add more water molecules around the system, but the hydrogens from the water molecules still act as electropositive areas. So in conclusion, we can see that the water molecules are placed around the most electropositive areas, since they are placed around and close to our ammonia in the system, which we could see was the most electropositive area. But because of this, we also can conclude that we make the assumption that enough water molecules could make the shift of the most electropositive areas around the ammonia, so that they could place other places into the system. Yeah, and then we can make a new method to develop in the future to place our water molecules based around the electrostatic potential. And this is my references, and thank you for your time.